Hey, good afternoon, everyone. Welcome to our March Sustainability Chat. My name is Casey Meehan. I am the Director of Programming here at the Sustainability Institute, and we are really thrilled to have you with us and have folks from Trane with us to talk about residential heat pumps. It's March 28th. The weather here in La Crosse, Wisconsin is looking nice today. It's sunny out, it's getting warm, but I know, having been born and raised in Wisconsin, that Mother Nature is just fooling us. So we have more cold weather coming this way, I'm sure. That's why talking about heat pumps, residential heat pumps, is, I think, just a very timely issue right now. So if you've never been to a sustainability chat session, just a couple of housekeeping reminders here. We ask that you keep your microphones and your cameras off for the duration. It just helps our streaming a little bit. Typical format here, we'll have about a 20 or 30-minute session from our guest, and then we'll have time to field questions from you. So to do that, please put your questions in the chat box. So on your Zoom screen, you should see a little bubble, conversation bubble somewhere on there. Click on that. You can enter in your question. Or if you've got a concern, enter it in there as well. We will be monitoring that throughout, and we end up collecting those questions, and then we'll be able to ask Mark, our guest, at the end a series of those questions. So if you have anything, please type it in there. Before we start, though, we've got just a couple of quick poll questions for you, just to get a sense of where we're all at here on this call. So there's two questions. If you could take a couple of seconds to answer those. What type of heat source do you have in your home? And then, were you aware that the Inflation Reduction Act of 2022 includes credits and rebates for heat pump retrofits? Maybe 10 more seconds to answer. All right, so it looks like 90% of us on this call are using gas furnace, and about 60% are aware of the IRA, Inflation Reduction Act, and how that includes some rebates for heat pump retrofits. So thanks everyone for the information there. That's going to be helpful as we move ahead. All right, so our work here at the Sustainability Institute is guided by the UN Global Goals, which are a series of 17 interconnected goals that help sort of move all of us and move the world towards a better place by 2030, really by addressing the biggest challenges that we're facing right now, including climate action and climate change. So two of those goals are really applicable to today's presentation. One of them, sustainable cities and communities, which is all about making sure that our housing in our cities have the technology and and they're sort of fitted out and adapted to climate change, and then also climate action. Now, La Crosse has passed a city climate action plan, which looks to reduce our carbon pollution to zero by 2050. So that's a great goal. Much of this, of course, is going to fall on big businesses and us collectively pressuring those big businesses to change. But there are still some things that we as individuals and as residents can do. Now, I really don't like those 10 simple things you can do for climate lists, because I think they're a bit of a distraction. They make us focus on a large number of small decisions that they're asking us to do really frequently, right? Like recycling, take shorter showers, turn off the lights, unplug your appliances. More productive, I think, would be thinking about a small number of big decisions that we make infrequently that actually, turns out, make up the bulk of our household carbon pollution. So, we just need to make 4 or 5 of those big decisions well, and we can forget about a lot of that hand-wringing that goes on around all the small decisions that we're trying to figure out. And one of those big decisions is how we choose to heat our house. I would imagine that most of us, and actually we look now with the poll, 90% of us have natural gas fired furnaces. So first, let's start with a misnomer of natural gas. Natural gas is methane. Natural gas is an energy industry label designed to make us think that methane is better than it is, right? And so, well, yes, natural gas furnaces are more efficient and cleaner than, let's say, oil burning furnaces. They still cause massive amounts of air pollution. In fact, methane is 80 times more potent than CO2 in the first 20 years that it's in the atmosphere. That's incredible. So that's a big thing to work on, right? Is methane reduction. And we know that humanity's ability to cut back pollution over the next 20 years is going to be really crucial to determine the quality of life for generations to come. So one of the most impactful decisions that you can make, and hopefully one that it's a decision that you don't have to make very often, is how to replace your broken down furnace. And one of the best things you can do is replace that broken down furnace with an electric heat pump. The lifespan of a gas furnace is roughly 15 to 20 years. So imagine that. If today you decide to replace a gas furnace with a unit just like it, you're committing your household to burning methane from now until approximately 2038, producing tens of thousands of pounds of carbon pollution in the process. So one solution that's been around for decades is an electric heat pump. Once this tech, at one point, and actually up until the recent past, this technology was really considered good for only warmer weather climates, but that's no longer the case. Joining us today to talk residential heat pumps, way down from Tyler, Texas, is Mark Woodruff. Mark has 20 years in the HVAC industry and is currently the air conditioner and heat pump product manager at Trane Technologies. So Mark, thank you so much for joining us, and take it away.
All right, let me share my screen if you don't mind, and you let me know when you can see it.
Yep, it's up, although it's not in presentation mode.
Oh no, okay, hang on one second. I believe there is a way to switch that. How about that?
There you go. Yep, you're all good.
Perfect. Okay. All right. Yeah. Hey, Casey. Thank you. Appreciate that introduction. Like you said, I'm going to talk about heat pump technology, specifically around the application of heat pumps in northern colder climates, and then some of those new technology advancements that he was talking about and how that's kind of shifting and changing how we can use and apply heat pumps up in the colder states. So we will go ahead and get started and start off with just a quick background around heat pump design, just in case you're not familiar. So you might not know that heat pumps have been around since the 1960s. So, certainly not a new technology, as we've had them around for over 60 years now at this point. And so, lots of history with the technology. It's certainly not new, very reliable, and has been very, very popular in the southern states for a really long time. I think, as everybody's aware, the difference between a heat pump and an air conditioner, of course, is that the heat pump can provide both your cooling and your heating using the refrigeration system. And then the third bullet point there is starting to talk about the application of a heat pump in the north. One of the barriers there traditionally has been that the heating output, or the amount of heat that a heat pump can deliver to your house, is a function of how cold it is outside. And it's an inverse slope. So as it gets colder outside, heat pumps, traditional heat pumps, actually deliver less and less heat as it gets colder and colder, which is the opposite of what you want, right? If it's 50 degrees at your house versus 0 degrees, You need more heat when it's 0 degrees to keep your house nice and warm versus when it's 50 degrees. So a heat pump is going the wrong direction in terms of its heat output. And that is different than a gas furnace. If you have a 60,000 BTU gas furnace in your house, it's sitting in your closet or your basement or wherever it is, and it's going to deliver 60,000 BTUs of heat no matter what, right? It's going to turn on. It does not care what the temperature outside is. It's inside your house, and it will always and forever deliver 60,000 BTUs of heat, right? So there's a difference there in, heat pump capacity starts to decline as it gets colder, whereas a gas furnace delivers a nice constant capacity line. And so, the question for years and years has been, okay, well, how can we make heat pumps act more like gas furnaces? How can we get them to provide more constant heating output? And that's some of what we're going to talk about today, are some of the technologies that have come out here recently that are starting to kind of bridge that gap and make heat pumps capable to operate, closer to the heating output of a gas furnace. So we'll talk about that here in a couple slides. The two most popular types of heat pump systems in the industry today are either fully electric or what we call partially electric, or we call those hybrid systems. And I have a picture of those over on the right-hand side of the slide. So a fully electric heat pump uses a heat pump and an air handler. And if my mouse will work here, so inside of this air handler, there's a blower, a coil, and some electric heating strips up here. And those electric heating strips, those are your supplemental heat. That's your backup heat. When the heat pump runs out of capacity and can't supply enough heat anymore, what happens? Well, the strip heaters kick in and they supply the extra heat that's needed. The difference between a fully electric heat pump and a hybrid system is that backup heat. So in a hybrid system, your backup heat is a gas furnace. So you still have a heat pump outdoor unit. You still have a coil, just like you had in your air handler, but you keep the gas furnace. And so just like, a hybrid car that tries to run on electricity as often as it can, and then it switches to gas when it can't, right? A hybrid heat pump system does exactly the same. It runs on electricity on the heat pump as often as it can. And then when it runs out of capacity to supply to the home, it switches over to the gas furnace instead of to strip heaters like it would with a fully electric air handler system. So those are the two most common types of heat pump systems that we see in the industry today. I would say most recently with more rebates and incentives and things like that coming out in the northern states to try and get people to adopt heat pumps, a lot of those rebates, hybrid systems qualify for those. And so we're really starting to see hybrid systems in the north become more and more popular because homeowners like the fact that they can get a system that qualifies for a tax incentive or a rebate or something like that. But they also get to keep the safety net of their gas furnace for those really, really cold days if they're, really worried about the heat pump being able to supply enough heat. So those are really becoming popular in the north. But then that last blue text there, yeah, so heat pumps are becoming more popular today due both to the green initiatives that we see with the rebates and everything, and the tax incentives that we'll talk about later. All right. I thought it would be good to show you what heat pump sales look like all across the country. And so I put this slide together using some industry data. So this isn't just my company and our sales. This is actually the full industry data that we're looking at here. And I took the states and I separated them out based on the heating design temperature. And the easiest way to think about that is what's the coldest day of the year? Okay. So for example, down here in the blue states, down in the South, where the coldest day of the year is between 20 and 42 degrees, you can see heat pumps make up nearly half the market. 45% of people every single year buy and install heat pump systems here in the South. So really, really popular when the temperatures are mild, right? When the coldest day of the year is between 10 and 20, they're still really popular, 40%. So you're starting to lose, 45 down to 40, but still really popular. You don't really see a decline or a major decline in heat pump until you get less than 10 degrees. So when the coldest day of the year is between 0 and 10 degrees, that's where heat pumps make up only 15% of what people buy every year. And that's not a surprise. Actually, we can look at the data and I can show you, there's kind of a magic number right around 5 to 10 degrees that we can talk about why there's such a sharp decline there between having a heating design temperature or a coldest day of the year being above 10 degrees or below 10 degrees. I'll show you that. As you go further north, when your coldest day of the year is between 0 and -10, heat pumps are only 5% of the industry. And then when you get really cold, -15, it's less than 1%. So there's 5 people up there that use heat pump. But it's not 0, right? Somebody's using one. So I would say that while heat pumps are used in virtually all of the markets today, you can clearly see that they become less popular as you go further and further north. However, that is changing and heat pumps are becoming more popular again because of those incentives and rebates and then changes in technology that we're going to talk about. So I hope that was helpful just to get to see, what does heat pump usage look like across the country. I think that's a good quick view of that. So now we're going to talk about heat pump applications and especially as we talk about using them in northern markets. So I've got this graphic over here on the right-hand side of the slide, and I'm going to reference back to this picture a lot through the rest of the presentation. So I'll kind of want to set this up and make sure everybody understands what this is. But this is the heating capacity that the heat pump can deliver versus the outdoor temperature. Okay. And so what we have down here across the bottom is the outdoor temperature. And so as you go from right to left, you're getting colder and colder and colder outside. And if you'll notice, as you go from right to left, well, we're also going down in heating output. So that means as it gets colder outside, a traditional heat pump system, and when I say a traditional heat pump system, really what I'm talking about is like a single stage or a 2-stage heat pump, which is the most common type of heat pump that started back in the 60s and then is still the most popular today. But those traditional heat pumps, you can see the slope of that line, how it gets colder outside. They start to deliver less heat as it gets colder. Now, the great thing about these traditional heat pumps is they've got a simple design, they've got low cost, and far and away, they're the most popular system for the folks down in the South. The limiting factor as you talk about trying to use those traditional systems up in the north is their lowest operating temperature limit. So if you'll notice, my line stops at 10 degrees, right? I'm not showing anything past that. And that's because somewhere around 5 to 10 degrees, there's just not enough heat in the air left for the compressor to operate correctly. And so the system has to shut down. The heat pump stops operating. And so that's why when we looked at heat pump sales across the country, you saw that once the temperature went below 10 degrees, there was really a sharp decline in heat pump, usage. That's kind of the reason why, is because, traditional heat pumps kind of had a technology barrier where below 10 degrees, you started to lose the capability for that heat pump to operate. So that 10-degree limit really limits, or has limited in the past, fully electric heat pump applications in the north. Now, hybrid systems, still a great choice, right? Because you get a low-cost heat pump system design, especially if you're able to get one that qualifies for, tax incentives and rebates and things like that. but then you've also got the gas furnace backup, and hybrid systems in a lot of cases qualify for those rebates, that they're qualified for those. So still a great application for hybrid systems, but if you're trying to go fully electric, that's been a limiting factor there for heat pumps in the past. So that talks about traditional heat pumps. Now I'm going to move on to the first technology advancement that happened about 12 years ago, that helped us start to move the needle, helped us start to apply heat pumps further north. So these are called variable speed systems. You may have heard those before, but this is a type of heat pump that has a variable speed compressor and an inverter drive. And so it has the capacity to ramp the compressor up or ramp the compressor down, depending on how much output is needed. And they have a little bit of extra heating capacity because they can boost the compressor up a little bit at colder temperatures. And so if you look at this blue line, this is the heating capacity line for a variable speed system. And if you'll notice, at any given temperature, now you're getting more heat output than a traditional system, and that's good, right? And you also get a lower operating limit. So this blue line stretches all the way down to about 0 degrees, right? So you're getting more heat at any given outdoor temperature, and you can operate at a lower temperature before the heat pump system cannot operate anymore, right? So you've made improvements on both sides of the spectrum, right? So that's good. Those are the positives. Now the negative, of course, is the cost. Generally speaking, if you talk to a dealer and get a quote and everything, generally variable speed systems tend to be about 1.5 to 2 times the cost of a traditional, like a single stage system, for example. And so, there's a barrier there. But again, with rebates and tax incentives and things like that coming out, that's really helping to offset this cost difference. We've seen that help a lot here recently. So variable speed systems have really helped heat pump adoption in northern climates. We've seen that over the last 10 to 12 years. But even with a 0 degree operating limit, which is much better than a single stage, right? That still prevents some markets from choosing to be able to go fully electric. And that's where the most recent technology that's come out is called vapor injection cold climate heat pumps. And if you'll notice this orange line, now we're getting even more heat than a variable speed system, right? And an even lower operating temperature limit, down to about -20. And so again, we've made improvements again on both sides of the equation. You're getting more heat, and you can operate down to a lower temperature. The heat pump can operate at even colder outdoor temperatures. And so that's a good thing. The con, again, just being the cost, that these are generally about 20 to 30% above the variable speed system that we talked about before. So the takeaways for these vapor injection cold climate heat pumps are that they can function in virtually all of the markets across the US. Cold day of -20 satisfies the vast majority of markets across the US, which is great. The Department of Energy had what they called the Cold Climate Heat Pump Challenge that they issued about 1.5 years ago. And the goal of that challenge by the Department of Energy was to incentivize American manufacturers to launch vapor injection cold climate heat pumps. And they were successful. Our company is one of several that participated in that challenge. And in response to that, we've developed these new vapor injection systems, and those are now in what we call the field trial process. So they're in homes all across the country. And I suspect that in the next, year or two, we'll have those ready to launch to production. So we're looking forward to that. And then on the cost side of things, again, rebates and tax credits and incentives are helping to offset those differences in the product cost. And speaking about these rebates and tax credits and incentives, I do have a slide on that. So I think that there was a question that was asked on the front end around, was everybody aware that the Inflation Reduction Act included tax credits and rebates specifically for heat pumps? And so what I've got here is just a snapshot and a summary of the Inflation Reduction Act and some of the tax credits and rebates that are inside of the Inflation Reduction Act. The first one is what we call the 25C tax credit, and there's a heat pump tax credit of up to $2,000 for a heat pump, which is fantastic because the prior tax credit for heat pumps had always been around $600 or so. So now they really, they're really recognizing that they want to incentivize homeowners to adopt heat pumps, and so now they're providing much more money to be made available if a homeowner goes with the heat pump. So that's on the tax credit side. And then over here on the rebate side, we don't have all the details here yet. The Inflation Reduction Act basically told the states, hey guys, you need to go write some programs to incentivize heat pumps, but they gave some guidelines. And in those guidelines, they said that, they would suggest up to $8,000 for income-based rebates for heat pump adoption. And then there's another program called the Homes Program that would, they suggested $4,000 rebates for heat pumps. And for those homeowners that would qualify as low income, that could be as much as $8,000. So again, those numbers and dollars aren't set yet. The states have to develop those rebate programs, but those were kind of the guidelines and the information that was in the Inflation Reduction Act. Okay. So kind of a summary and a wrap up here. When you think about adopting a heat pump in northern climates, we talked about the two major considerations. We talked about one of them, quite extensively, right, which is geography. And of course, applying a heat pump in the south is easier. And then as you go more north, it becomes more difficult, right? You have to move up, move up to those variable speed or vapor injection cold climate heat pumps. Or in the cases where hybrid systems can apply, you need to look at those hybrid systems and potentially go that route. And then the thing that we didn't talk about is home construction. So it's a lot easier to apply a heat pump in new construction where the builder really has control over the envelope of the house, right? Because he can look at the heat pump curve and he knows that, okay, well, it gets as cold as 5 degrees in this area. And so I need to make sure that the heat load at 5 degrees, and size the system correctly for that. But really the builder is in control of everything, right? And so it's a lot easier to design a home to accept a heat pump when it's new construction versus when you're talking about an older home where you're doing a retrofit, where the home is what it is, right? Unless you're going to spend a whole lot of money on insulation and windows and things like that, you kind of have what you have. And so those can be limiting factors when you talk about, the heating load, and it's just easier to adopt those all electric heat pump systems in the north when it's new construction. So I think I'm right. That was my last slide. I know it was short and brief, but I was told that was a good thing, just to give you guys an update on heat pump technologies and applications in the north. So I guess, Casey, if you want to jump in and take it from here.
Yeah, we've got all sorts of questions that are coming in. So Mark, thank you so much for sharing your expertise with us. One just point of clarification, when you're talking about outdoor temperature, are you talking about actual temperature or wind chill?
That, my understanding is that should be outdoor temperature.
so that does or does not include, so that's actual, or does that like, or are you
Actual,
talking about wind chill as
I
well?
believe it's actual temperature. Yeah.
Okay, gotcha. Because I mean, here we'll see days that are, maybe 0 degrees or -10, but then with the wind chill, it gets down to, could be -40.
Right.
Does that impact then the what a heat pump can do?
I think the best thing there would be to talk to your local dealer about the application there. I don't want to lie to you. Again, my understanding is it's actual absolute temperature, but I don't want to steer you the wrong way.
Got it. Got it. What about that last slide you touched on, just the importance or new build, right? And the ability to have things nice and sealed and all that. How important is that? How important is insulation and well-sealed buildings to heat pump performance?
Yeah. So it's all about capacity, right? So as you add more insulation or you do a better job of sealing, leaks and things like that in the house, or better windows and things like that, what you're doing is you're reducing the amount of heat that the heat pump needs to provide, right? And so if you remember, there's that curve, that declining curve of how much heat the heat pump can give. And so if you're in a replacement situation, it could be that at 5 degrees, your house just needs more heat than a heat pump can give, right? You need a 80,000 BTU furnace, for example, right? And you need 80,000 BTUs of heat. Well, we don't make 80,000 BTU heat pumps, right? Especially one that will give you 80,000 BTUs at 5 degrees, right? So adding that insulation, sealing things up, that brings down your heat load. And so now you need a smaller heat pump to supply the heat load that you have at those colder temperatures. So that's the improvement that you're making there.
And how about, could you talk a little bit about when, I guess, first of all, when is it appropriate to actually replace our furnace? So should we wait until that gas furnace dies before replacing it, or do we replace it before that? What's preferable? Does it matter?
I mean, my opinion is that's kind of a personal choice, of what you'd like to do. Like you said, heat pump or gas furnaces I've seen them last 20, 25 years easily, right? And so people will go through 2 air conditioners before they have to replace their heat pump. And who wants to spend more money before they have to, right? I think most people are going to extend the use of that gas furnace as long as they can. But again, I think it's a personal choice. It's one of those things where, maybe you only have an 80% gas furnace, but you'd like to upgrade to save on the gas and lower your bill, and it makes sense to do that. But I think it's a personal choice of what you have in your house versus what you're looking to move to, and do the finances make sense?
Mm-hmm. We've got a couple of people that are really interested in hybrid systems in particular. So, and I think different types of arrangements. So, could you comment on hybrid systems that use electric furnaces as backup? And can a person keep their existing gas furnace and then add a heat pump in parallel?
Yeah, so the first question was around electric furnace, which is basically strip heaters, right? So if you have an electric furnace, now you'd be replacing that electric furnace with an all electric heat pump system. Or if you wanted to replace your electric furnace, which is heat strips, with a gas furnace, you would do that. But that, I think those are apples and oranges, right? The question around, can you keep your old gas furnace and just add a heat pump? The answer is absolutely yes, you can. And that's one of the most popular things that we see, is, hey, I've still got 10 years of useful life on my gas furnace, but I want to go ahead and take advantage of this heat pump tax credit that's out there right now. Well, hey, you can do that as long as the rebate or the tax credit is qualified for hybrid systems, which a lot of them are. But yeah, you can absolutely do that. You can go with either a full system replacement and get the best efficiency, or you can reuse that old gas furnace. Not going to get the same level of efficiency out of it from on the electricity usage side, but still an absolute option that's out there. Yep.
So we've been talking mainly about air source heat pumps. Are there, what can you tell us about geothermal heat pumps, and what are the advantages and disadvantages of geothermal versus air source?
Yeah, I am so much less familiar with geothermal that certainly not an area that I should be getting into.
Fair enough, fair enough. Um, what is the generator capacity needed to run a heat pump?
Um, I don't know the exact number, but certainly it is significantly more than, for example, a hybrid system. Let's say that you were in a situation in the north where you lost power, um, and so your heat pump goes down, but you've got that backup gas furnace, right? Well, a gas furnace can operate on the same amount of power as a light bulb, right? So it's like 80 watts, 100 watts, something like that, right? So um, certainly in those situations where you're worried or would like the capability to use not a lot of power with a generator, the hybrid system is a great answer. I cannot remember offhand how many watts a heat pump system uses. I don't know that offhand.
And how about, let's see, just scrolling through the questions here. Can any furnace at all be paired with a partially electric heat pump?
Can any gas furnace? Yeah, I would say for the most part, I cannot think of an example. Um, we have what we call our ratings for our systems, which are called coil only ratings, and we have those ratings out there to apply any gas furnace. And so there may be some limitations where if you're wanting to use one of the more advanced heat pumps, that the gas furnace that you have just doesn't have those capabilities built in, and so you would need to upgrade the furnace. But if you're talking about a basic system, for the most part, yeah, the answer is yes.
And what about any other type of furnace? What about an oil furnace or anything like that? Can those be paired with heat pumps?
That's a good question that I don't know the answer to.
Got it. How long does the typical heat pump last?
Heat pump, excuse me. I would say generally about 15 years, 12 to 15 years. They typically don't necessarily last as long as an AC because they have more runtime, right? And AC only runs in the summer, and so you're only running a certain number of hours, whereas a heat pump you're running some portion of the winter as well, right? And so you just got more runtime on it. So it's going to be less than an AC, but generally speaking, of course, where they're most popular right now is down in the south. We're seeing 12 to 15 years pretty consistently.
Sure. And speaking of the AC side of it, what type of cooling capacity does an air pump have?
So most heat pumps are sized. We have 1.5 tons of cooling all the way up to 5 tons of cooling. And it's, that's true for the cooling side and for the heating side also.
Got it. So would one, if they were interested in putting in a heat pump, how would they size that? Do they size it by the amount of heat that it puts out first, and then
Yep, that's where when
AC
you call a dealer and you tell him what you want to do, the first thing he's going to do is a heat load calculation. He's going to figure out, okay, well, it gets this cold in the wintertime. He'll assess your house and say, all right, well, this is how much heat you need, let's say at 5 degrees, right? Based on your home construction and your window type and your insulation thickness, south facing, all that kind of stuff, right? We'll say need this much heating capacity, and based on that heating capacity curve that we looked at before, he would say, all right, well, here's the heat pump that you need that gives you that much capacity at 5 degrees, as an example. So the answer is the dealer figures all that out for you. You don't really have to worry about it.
Sure. And speaking of that, what training are dealers and installers being given? I mean, clearly, like this is a pretty popular thing in the South, but not so much up here in the northern states. Local dealers right now, so far, don't seem to be all that well informed about all these options. What type of training are they getting? Do you know?
So I've heard that it's absolutely true that in the past, in the north, the rule of thumb was thou shalt get an AC, right? And so heat pumps were not discussed that much, especially, you know, in the trainings and things like that. Because rebates and tax incentives and things like that are really starting to gain traction and get homeowner attention. I have seen a lot of the distributors, you know, put on training programs, and they're starting to include more heat pump application in their trainings.
Great.
And so, you know, whichever brand, if you're a dealer, I don't know if that was a dealer speaking or whatnot, but yeah, whatever brand you're dealing with, the distributor that you're working with, I would presume if they are not already doing it very soon, they're going to be adding more heat pump curriculum.
Sure. With a comparison to a gas furnace, a heat pump would be using more electricity and less gas, right? Virtually zero gas if you go all electric. Can you comment at all about, you know, what's the savings in terms of money, or greenhouse gases, or both? Like, how does this match up apples to apples?
There are PhDs getting their degrees trying to answer that question. It depends so much on what are your utility costs and where is your energy coming from. Those are the two main inputs, right? If your electricity is coming from a natural gas plant, well, right, there's the answer there, right? And coal and things like that. I think what we're really going to see is as the power grid, you know, becomes more and more sustainable and uses different technologies and things like that, the pendulum kind of swings. We've done individual studies in different markets, and again, what we saw was, you know, was there dollar savings to a homeowner? Well, it depends on what they had versus what they went to. And what are their utility rates, you know, gas versus electricity. I mean, it was all over the place. And then same thing on, you know, greenhouse gas emissions and things like that, trying to understand to what extent, you know, different technologies are greener or not. It's just so dependent on what the grid's using. It's hard to say.
Sure. So there's a clarification to a question that was asked earlier from Rob. He's wondering, can an electric furnace be paired with an electric heat pump?
So my understanding is an electric furnace is basically a sheet metal box that has a blower in it and it has heat strips. And so yes, I believe that we have ratings out there that would allow you to put a coil underneath that blower and use the outdoor heat pump. And so your old electric furnace, your old electric furnace, you're basically building an air handler, right? Because an air handler is a blower, a coil, and heat strips. So you're kind of building your own air handler there. So I guess in that situation, the answer would be yeah. We do that a lot in mobile homes down here in the South, right? Because the mobile home companies ship the mobile homes just with electric heater boxes, blower and strip heat. And then, yeah, people in the field add either an AC or a heat pump.
So vapor injection technology that you were talking about, can you clarify a little bit the timeline of that? When do you expect that type of unit's going to be available to the masses?
So all of the major manufacturers that, you know, participated in the Cold Climate Challenge to kind of to get that development of that technology started. Right now, we're all tied up with something called low GWP. So right now, the most common refrigerant that is used in our ACs and heat pumps is called R410. Starting January of 2025, we can no longer manufacture equipment using R410. So we're having to redesign all of our equipment, every outdoor unit, every air handler, every coil, everything, to use a new lower global warming potential refrigerant, which is great for the environment, and we're happy to do the work. But that is taking away all of our resources and engineers and test labs and everything. And so I suspect it's going to be sometime after we finish all of that development for the new refrigerant that's coming out, that we'll really get to start to put an effort towards launching that product. And so in my mind, it's going to be sometime late 2025, early 2026 would be my guess.
And do you know, is that technology just getting better and better all the time where, where temperature, wouldn't it be great, I guess, in 10 years or 15 years if temperature doesn't matter where you live, but temperatures, no matter how low it gets, and a heat pump would work? Is that, am I just sort of living in like a utopia right now? Or is that something that's physically, according to the laws of physics, is that possible?
It's hard to say, right? Every time you say that can't be done, somebody finds a way to do it, right? So it would not surprise me if exactly what you said is true. It's going to get better and better over time, even if we can't see it today.
Just two, let's see, just two more questions that are connected here. The rebates and the incentives that you were talking about, are those stackable? Like, can you get, so you mentioned, I think there's one that was worth $8,000 and one that was $4,000. And can you actually stack those up and for a heat pump, or is it sort of one or the other?
We don't know yet. So if you remember, there were two sides to the slide, right? One was tax credits and one was rebates. The tax credits, even though they're not 100% final yet, I would say they're more baked. The rebate side of the equation, though, that is 100% incumbent upon each individual state writing a program, developing some rebate system, and here's what equipment is going to qualify, and here's how you submit for your rebate, and here's the paperwork you got to fill out. Every state has to develop that full program and release that and roll it out in their individual state. So far, nobody has done that, and it's because it's a lot of work. It takes time, right? The Inflation Reduction Act just kind of got dropped in everyone's lap overnight, right? And so there are people working on it every day, but so far, none of those rebate programs have been released by any of the states. So we have zero detail that would help us understand if things are going to be stackable, and if that $8,000 is even real, right? A state could say, well, we don't really want to give 8,000, we want to give 6,000 or something like that, right? We just don't know yet.
Got it. And here's a question from our friendly neighbors to the north in Canada. Are you aware of any Canadian rebates?
The biggest rebate that I'm aware of, I think, is called the Canada Greener Homes Program. And there are two different programs. One is a $4,000 heat pump program, and one is a $5,000 heat pump program. And I think they have different equipment qualifications, right? You can, for the $4,000, the equipment doesn't have to be as efficient. For $5,000, the equipment has to be more efficient. I think that's the delineating factor there. I think in Canada, that's the biggest one I've heard of, or that I'm aware of.
Got it. Mark, thank you so much. Just out of respect for your time and everyone else on the call, thank you so much. We had a lot of questions. We actually had to put a pause out there in the chat box for questions. So thank you for sharing all that information. I think heat pumps are coming. I think that the money available in incentives and tax rebates, I think, is going to go a long way, and it's going to help all of us out. So thanks for the work you're doing on that, on the engineering side of it and the marketing side of it. It's just getting this type of product and an idea in front of people, especially up here in the north, where it's not very common for us to run across the heat pump. So really appreciate your time. Absolutely. Just remember, whenever you're ready to replace your system and go with a heat pump, just call a Trane dealer. Right. Shameless plug. I love it. There you go. Everyone else, thank you so much for participating. We've got a few announcements at the end here. But first, actually, we'll do this right away. Carrie, do you want to talk about the Green Goose Chase?
I do. Thanks, Casey. I just wanted...
Let me put it up on the screen here. There you go.
Thanks, Casey. My name is Carrie Thompson. I'm the executive director here at the Sustainability Institute. Just wanted to say thank you again to Mark for presenting today. It was a really great presentation. For those of you who are aware, this is our third annual Green Goose Chase. It's coming up and starting on April 21st, so make sure to get your team ready. If you haven't participated before, you can head to our website, sustaininstitute.com/Green Goose Chase. I think Casey's going to drop it in the chat. This is a mission-based team scavenger hunt that we put on here in the La Crosse region. Our goal is to help people experience local sustainability, explore nature, learn more about the Good Life goals and green practices, and most importantly, have a lot of fun and a little competition. We wrap up at the Earth Fair, which happens on April 30th. We give away some free and great prizes that you can find on our website. And last year we had close to 100 teams. So this year we're hoping to break that mark. So you can be a team of one or a team of many. We have families, we have coworkers, we have neighbors, all different types of teams. So if you haven't participated, check it out. If you have participated, come back. We have over 40 plus missions that we will be debuting this year. Some that you do from home, some that you do out in the community. It's a lot of fun.
Awesome. Yes, please do think about joining up with the Goose Chase. It is a ton of fun. We've seen nothing but great engagement from the community in the past couple of years. So it's just a good event to be part of. So before we go on, we've got just a quick poll to send out, which I think Carrie's going to put on your screens right now, just getting some feedback about the presentation today and what we're doing here at the Sustainability Institute. So if you could take a few seconds to answer those 4 questions. And I would like to say that if you enjoyed today's program, if you like what Sustainability Institute is doing, none of it is possible at all without our members. So thank you very much to our promoter, champion, and advocate members, Wade Hackbarth, Glenn Jenkins, Jacob Siamas, Raj Schnick, Dorothy Leonard, Strive to Thrive, Habitat for Humanity, and a special thank you to Lee Rosh and Lynn and Todd Huffman. Again, this free programming wouldn't be possible without them. If you like what we're doing and you want to become a member or donate, please do head to our website, sustainинstitute.com, and you'll find at the top of the page, really clear, there's a become a member button and a donate button. If you choose to become a member, choose a level that's comfortable to you, and we welcome everyone to become a member. And finally, next, Carrie, are we good with the poll?
No, it's not quite working, so we'll have to skip that today. My apologies.
Gotcha. And finally, join us for our next sustainability chat. And actually in April, we've got a few great things coming up. So we've got a sustainability chat, date yet to be determined, but likely that last week or so of April. The Green Goose Chase, of course, which Carrie already talked about, and the Earth Fair is coming up at Myrick. This will be, gosh, I think our 13th or 14th or maybe 15th Earth Fair. I'm not quite sure where we're at now. Great celebration. April 30th, that's the last Sunday of April, down at Myrick Park from 11 till 5 p.m. Come on down and join us. It's a good time just celebrating sustainability, learning from folks, and just being in community. So again, thank you very much to Mark Woodruff for taking his time today and teaching us a little bit about heat pumps. Thanks to all of you for joining us today, and we'll see you sometime this month, I'm sure. Take care.